Hi, Tim Span here, Principal Developer Advocate for Milvus Vector Database. I want to show you what we did in this article. If you haven't seen the article yet, it's linked below. Also, give me a like. I don't have a million likes like some of those awesome videos out there, but I'm working on it. Let me know what I can improve. So we're going to cover some of the material in this article. Basically, how to write a Python app to get this JSON data, vectorize it, get it into Milvus, do some queries on it, do some filtering on it, showing you why adding JSON data to our vectors is cool. If you like this, want to do more unstructured data, I have a meetup in New York and in Princeton. We also have other meetups, San Francisco, Seattle, South Bay, Berlin. So we got a lot of stuff going on. So you could definitely come out to those. If you can't make it, we will have YouTube videos recorded, maybe stream live. Depends on the venue, what's going on. Some of the other speakers might not like it. We'll play it by ear. We've got meetups next week, and I've got some coming in July and August, and they're happening all over the world. So definitely check those out. Also check out my website here. I try to link all the cool stuff, and I've got a weekly newsletter. All those links are below, but let's look at what we were doing. Now we have our data stored in Milvus. I already ran this, as you saw in the article. So I'm going to go to my default database and the New York City collections. You can see I've put like 10,000 vectors in there. They have an ID that's an int64. They've got a vector. It's a vector of some text, as you can see here, 384. And also we've got that JSON field. And if you've seen that quantization article, which may not be out yet, we got one of those indexes there. So lots of data in here, and we could browse the regular data and just look through it all. But you might want to filter it a little bit. And I just put in a vector from our data, but you could put a random one in there. And more importantly, and you could tweak search parameters, top K, consistency, lots of fun stuff. But you could add filters, and you could even filter on that JSON field. So inside that JSON field is a individual element called borough, and I want to look for Manhattan. So I'm going to get back all the results for Manhattan, or at least 250 of them. That's a good way to do that. Cool, as you saw, it's fast. If you want to look at code to do that, press the button, gives you most of it. Doesn't put the filter in there yet. I'm going to harass the engineers on that one. And you can also download it as a CSV. Very cool. Now you can also do different ones here, and I'll show you these same ones in a notebook. If you want to run a notebook, I've got one here to do searches. Let's make sure we start off fresh every time you do something in a notebook, especially for a demo. Start off fresh. We'll reconnect. You can see that dimension there. This is my own little Docker server. That's the name of the collection. Now, if we wanted to run locally with the new Milvus Lite, just put a DB there and it'll store it locally. Very easy, doesn't need distributed server. But again, running in Docker with the distributed server with etcd and all the other services there is a good way to test out how it's going to run in production in Kubernetes or in Zill's Cloud. But let's get to the next one. So we connected to our database, then we did a little search. Here I took one of the rows and vectorized it with this sentence transformer embedding. And we'll use that as part of our search. But here's our filter. Filter back any one where the first vehicle in the crash was a taxi. Gives back the ID and that JSON field. And as you can see here, we got all those nice records there in our result. And you could see how close it was to our thing. This was the exact record I used to vectorize, so it should be there. The other ones are pretty similar, similar thing. Maybe it's a street off. Records are pretty close. Run the next filter. This one's doing more stuff. We've got Manhattan. We got a type of vehicle, and we got what street. Now, there's not a lot of these that are on 11th, so we might not get a good result back for that. But we could take a look and do that same search. And we'll do a like here. It's on street, like, I think it was 11 Avenue. If not, we could just put Avenue. And maybe we screwed up there. Maybe we'll just do Avenue. Let's see. Okay, we got a couple on Avenue. We didn't get it. Oh, let's up our parameters here. Play with that later. Let's see. Yeah, we got a little more. Maybe we could switch it to make it a little closer. Maybe we can get 11 Avenue. Let's see. Okay, we get actually a bunch on 11 Avenue. So there's some here. Now we could export this data, then take a look at it. You know, pretty easy there. But you can, as you can see, if you want to add other parts of your filter, like maybe limit it to vehicle type, that's a good one. Is limiting to what vehicles can come in there. Well, let's see which one. Too many windows here. So pick that JSON field, this one, and we're going to do an in because we got a couple of these. And we got bus, we've got sedan, and we've got, what was the other one? Make sure we do it the same. Taxi. Okay. Interesting. Let's. Oh, wait a minute. Were they mixed case? Yeah. I don't have, where am I in lock? You guys should have told me. Thank you. Okay, let's make sure it's in the right case here. Okay, so we could see we've got a couple of these back. Pretty close. And again, we could export these. And if you wanted to see the code to do this, pretty straightforward. But that's what we have going here. That's, you know, filtering and finding our data there. Pretty easy. But how did we get it in there? We have a REST endpoint from Open Data for New York on these crashes. We can explore that with pandas. Take a look. Get the what it looks like. Okay, we get a feeling. This lat long could have come in real handy. What I'm going to do is add additional lookups and additional data here once I start iterating through this and improve this. If you saw the taxi article, I grabbed some of that taxi information, where it is in the city. I grabbed street cameras. We can grab weather. There's some, I've got some other transit information based on lat long. I can also use that to put that in an open source OpenStreetMap, and we could see where everything's going on. And this is helpful, so when we do the meetup in Manhattan, we could see what's going on and use our Milvus vector store to help us out there. So we read all that data. This is, I'm limited 10,000 records. That's a lot of data coming down. We connect to Milvus, create our schema. And here it's not dynamic fields. We got this JSON field, the vector, and the ID we mentioned. You can see here what's going on with parameters. We create our collection, make sure it's loaded, and then we could start iterating through those JSON elements. This is where we can add, because we have lat and long and we've got street, I can look up street cameras. I could do REST call, do some calculations. Actually, also send this data so it's not just going into Milvus. I could send this to Kafka. I could send this into Iceberg. I could send this into just Minio S3. I could send this into any other kind of database, because this is very structured data. So it may make sense just to have a pointer here and the other data in a relational database. Again, having it here, having it close to my other data may make sense for certain use cases. And maybe you don't want to have it for this particular example, especially if I'm going to run this just on my laptop. I'm not going to want to run, a huge thing. I could just put this in Milvus Lite and have this all local, which is nice. So we got all this stuff loading, pretty easy. And then down here, we just do a quick check to make sure the data got inserted and everything's good. Now, all those examples are in here in my GitHub. check it out. We've got the notebook and the search notebook, plus some of that exported data to explore. Hopefully, this showed you some things on the JSON field and why it's helpful. And it's pretty cool. Thanks a lot.